Welcome everyone. Today we have our another new episode, and this episode is very important because we will discuss about AI in healthcare diagnosis. We have our expert, Mr. Dan. He's a data scientist and AI expert. Even he has a lot of experience from healthcare industry. Beside that, we have our world famous speaker, Professor David Smith. So I want to start from uh, Mr. Dan, how you want to analyze today's topic. And beside that, I know you are from Transhumanist Party. Just last Sunday, we finished a debating tournament in Malaysia, one of the largest debating tournaments. Even we promote U.S. Transhumanist parties, and I'm sure that our audience, our young debaters, they are very motivated about U.S. Transhumanist Party because U.S. Transhumanist Party promoting modern science, engineering, and technology in frontline politics. So young people are very motivated. Hopefully, in January or February, we can arrange a debating tournaments. I believe many young and talented people will join in the debating tournament, and I want to invite transhumanist members. Anyway, Mr. Dan, how you want to analyze today's topic?
Sure. My background in education is in physics, but about 5 years ago, I switched into machine learning, and I have been working specifically on applications in medical imaging for about 3 years now. First, I was working at the National Institutes of Health with a radiologist doing research on new types of AI systems for radiology. And then more recently, I've moved to the Massachusetts General Hospital, where I'm working as a data scientist. And I'm actually helping with the deployment and the process of taking the AI software and actually moving it into use and testing in radiology clinics. And it turns out there's a lot of work involved in that process alone, and a lot of technical challenges. So my expertise is mainly in medical imaging. I believe medical imaging is maybe the area of healthcare that will be impacted the soonest, because essentially we have really good methods for computer vision, and radiology. Most of what radiologists do is basic pattern recognition from images. So that's something that we have pretty good AI methods for, with deep learning, convolutional neural nets. But I also think there's quite a few algorithms that are at, like, quote, human level, but they haven't. There's very few that actually have been tested in real world conditions for extended periods. So it's going to happen a little slower than you might think. I think it's going to take a few years, but eventually AI will be a standard thing in radiology, and then also pathology, looking and then more generally like clinical decision making. So I'm happy to talk about any of those areas if there's interest.
Thank you. We have our another world famous speaker, Mr. Sharidan Tatsuno. So we are discussing about AI in healthcare diagnosis, and we have good news. Like next month, from December 1 to December 3, we have very exclusive event with Rwanda government and corporation and academy for public-private partnership. And I'm very happy all of our speakers, those who joined today, I'm sure they will join in the upcoming event. Actually, a World Talent Economy Forum, we fully focused on economy and economical developments. I am from developing nations, and I saw that developing better economic and sustainable solution is very, very important for developing nations. That's why just last month we promote public-private partnerships dialogue in Malaysia with climate change departments. I want to say it's very successful. From Dubai Expo, Malaysian government already get commitment from around $7.8 billion investment. I think this is very good, and we have a plan for $60 billion. Then we are moving in Rwanda and another developing nation. So all of our speaker support is very important because they are from industry, they are from academy, they can guide governments and corporations, especially local corporation and government. So I request all of our audience, please engage with World Talent Economy Forum. Next 1 year, we will arrange many important dialogue and conference, which will be valuable for developing nations, especially for economical development. Mr. Sharidan Tatsuna, you are one of the expert for startup and developing nations, even their government and corporation trying to develop this startup ecosystem. But we are discussing about AI and healthcare diagnosis issues. So how you want to analyze these issues and how you want to share your serial entrepreneurial experience with our audience.
Okay, very good. Hi, Sheridan Tatsuno. I'm from San Francisco. I'm born and raised Silicon Valley. In fact, when I was a child, Silicon Valley did not exist. It was a farm town. I've seen the whole rise. I'm urban planner by training. I did that for the first career. And then I went into semiconductor, chip research, market research. Did a lot of consulting. I'm co-founder of my 11th tech startup, so I've done a lot. I used to advise venture capitalists 30 years ago on chips. I've pitched them. I know how VCs think. I know how startups work. It's not easy. We had one success IPO, Audience Inc. It's in all the Android phones around the world for audio processing. It's a Caltech spin out. So that was one out of the many that actually succeeded. In terms of medicine, I'm not an expert in medicine nor AI. However, I've worked on several areas. One is, and I'll give you the link in the chat. I co-founded a virtual reality company in Sweden called OneReality.com. And we were hired by HTC, which was promoting their headsets. And we created a virtual reality model of the Nobel Prize for Medicine, 2017, about circadian rhythms. And we had the 3 Nobel laureates advise us on the scientific basis on how they won the prize. And we showed that in VR, detailed VR. We had, in virtual reality, you always need experts with domain expertise, whether it's medicine, construction, and then the VR. The VR were gamers who know how to build the sets, but very few scientists or urban planners or engineering people know how to actually build a VR model. They're typically artists who've worked in the gaming industry. But if you pair the two, then you'll get scientific excellence from your domain experts, and then you'll also get your artistic accuracy and brilliance. So that one is the show. We showed it at the Nobel Prize for Medicine 2018. And the point of that for HTC was to show that VR is a very powerful gaming platform. We use the Unreal because it's used for more construction and engineering, and then you have Unity for games. Unfortunately, most professionals who don't know VR think it's just for shoot 'em up games, and they don't realize the power of it. So HTC wanted to show that you could go to the very highest levels of science and use it for actually training, research, medicine. One opportunity, when I showed the VR to an oncologist, a former professor of UC San Diego in oncology, that she said, basically VR is an immersive, the next generation microscope. And I said, what do you mean? She goes, well, think about it. You can upload all data, right? X-ray scan, CAT scan, ultrasound. I said, we can do that. And you can composite the data in 3D, We do it all the time. We fly around. We could show the cells dividing and multiplying, We fly through this blood cell. We can do that. Why? We could show anything you want. Why? Because that's a microscope, except it's based on real data. So the first question she asked, and we could do it, but I haven't seen it done. We call it the big C, cancer research. Tons of money going in. Right now, they look at flat plates. She said, can you build a 3D model of cancer? I said, yeah, of course we can. All we have to do is get the data and then composite it. And she said, can you show it growing? I said, well, that requires time lapse. So I don't know how much time. Let's say you do it every hour, and you grab the data, it's the same data set every hour. Then what you could do, she said, is apply therapy and see the reaction where the drugs go, and also you could see how it affects the cells. And I said, yeah, we do that all the time in VR. And we actually like going inside the cell. So we could go inside the cancer cell being attacked because it's just data. So in the future, this is kind of sci-fi, but we said, oh yeah, you could have the cancer patient and the doctor like walking around inside the cancer cells, the patient's cancer cell. And then what we did is you could use markers and say, okay, we're going to focus the chemotherapy in this portion only and outline the thing and mark it. And then you could do time lapse, and we do post-it notes all the time. So what we did for the Nobel Prize, we had to, for the functions on how the circadian rhythm work, we just had little, we call post-it notes, where we marked it, and then you had the Nobel laureates narrating what was going on and how they won. So for cancer, it'd be simple. You just have the doctor and the surgeons look at it, comment upon the cancer cell, the treatment, and then you just mark it. So you just bookmark all the sites over time. So I said, yeah, we could do that. But see, so for medical treatment, you can do it. Now, the other application in medicine, and it didn't occur to me, I got a phone call from a plastic surgeon from Austin. And they said, I said, what do you do? Like facial surgery? No, she was mastectomy, breast reconstruction. And I said, wow. And they said, can you use virtuality for that? I said, we could do it for anything on the body. Why? And she goes, well, the biggest concern that women have is the fear of disfigurement after their surgery. And they're worried about it. And we have to use all these plastic models and all to create, different options. I said, he said, can you do that in VR? I said, of course we do. We could have plan A, B, C, D, infinite number of shapes, whatever you want. And we could drop the clothes onto it to see how it's going to hang when they wear clothes. We do that all the time, in terms of the body. And he said, wow, that would be amazing because then you could visualize. So I said, for all plastic surgery around the world, anything, you could take and reconstruct a person without legs, prosthetics, what kind of prosthetics. In fact, one inventor in the Bay Area, what they did is they said he was dealing with people who were limbless, quadrupeds, people who lost their limbs. So he was designing legs, and you usually have these clunky, ugly legs. So one woman said, can you design it like tattoos? Because I like tattoos. And she said, what do you mean? He goes, tattoos. He said, yeah, I could do whatever I want because they're hollow. If you know anything about the prosthetics, they're very light titanium, and they design it. And then, so he said, can we do that? And I said, yeah. So he showed me in VR and 3D, a woman had this one leg, and they had a nice color. It looked like nylon socks. And then it had the tattoo on it, but it was a hole through it. So you could actually see through it. And so she was walking around town, and she had her tattoo in her prosthetic limb, which was designed as a tattoo. And then she had other socks designed differently or the same. And so her friends would look at it, and she used to brag about it. And she said, gee, I like it so much that maybe I'll get one different type of sock for each day of the week because I get tired of wearing the same leg. And I was saying, wow. So the point I'm saying is VR can be used for many things. It's already being used now. All medical research will be using VR in the future because you can see anything. The good part is you can not only create models, but you can also upload any data. And the challenge is creating composite models of X-rays, ultrascans, CRTs, and whatever you want. And building a database. What that means now is remote collaboration. And so, for example, we do it all the time. We could have people in San Francisco, Stockholm, London, Paris, doctors looking at the same model. In other words, a cancer patient or research or a class. You could have 5,000, you could have 100,000 people anywhere in the world watching that model while the professors or the researchers are pointing out, like the Nobel laureates, the different parts of the say, a body or the cancer spread, and you could record it just like we're doing now. And that's the future of medicine. You can do it today. Now, one woman called me from Palestine, and she said, I heard about the VR. Can we do that for remote telesurgery? And I said, what do you mean? He goes, can we, on the battlefront, we can't get doctors because it's not safe, but we have urgents. Can you do robotic surgery. And I said, theoretically, you could. You could just have, the nurses and the younger doctors there, and you could bring in a surgeon from any place in the world. Eventually, then the idea is to link it up with telerobotics to remote surgery on the battlefront, or in the poor. So let's say instead of flying around the world for medical tourism, in the future it might be you just go to the local clinic, put on your headsets and all, scan it in, and then the surgeon from halfway around the world is doing telerobotic surgery on you, and you don't have to leave your home or your town, which then medical tourism changes from traveling halfway around the world to the doctor just logs on like we're doing today, and you just do it right there with your surgeon. So I think people don't really understand the power of VR for medicine, and when you add AI to it, then you're on steroids, because think about it, with cancer, you could run scenarios. What if this, what if that? And then you could record any decision tree and run your algorithms against it and say, what's the probability of this happening and that? So cancer research is going to be heavily driven by AI algorithms and VR to not only predict which way it's going to go, but actually show the possible scenarios. And then based on that, you can compare it with the actuals. So then you can get a database that's validated against actuals. So, we were talking about a lot of these issues like 5 years ago, and it takes time. One recommendation I have is that medicine is very conservative, it's hierarchical. And I asked people at UC San Francisco on adoption of VR for medicine, and I ran into a lot of skepticism among the older doctors. And they said, well, that's for games and all that, and your typical stereotype. And I said, have you ever used VR? He goes, no, my grandchildren play games. I said, have you? And he goes, no, I don't play games. I said, okay. And so I talked to the younger doctors, 20s and 30s, and I said, would you use VR? And he goes, oh yeah, we're all gamers, bring it on. When are you going to use it? And I said, let me ask you a question. In the medical profession, this is 2015 or 16, 5 years ago, what's the break point between people who believe in your medical people using VR for medicine and those who don't? And he said 35 years of age. Beyond 35 years of age, they think it's a toy, it's a waste of time, don't bother us. But all below 35 said, we're all gamers. Yeah, bring it on. And I said, okay, I understand. So why don't you bring it on? He goes, it's simple. The old guys all make the decisions. And that's the problem. It's not because the technology doesn't work. It's because the people are old-fashioned during in the last century. And the young people are waiting to use these tools, and they're really powerful, as we proved. But it's a mindset problem. It's not a financial problem. It's not a technical problem. We have all the AI algorithm writers. We have all the VR developers. We have the medical specialists. That's not the problem. It's a mindset problem. So I recommended, I said, well, the way to get around this one's very simple. Is from now on in the future, for all new technologies, AI, VR, it doesn't matter. You bring in people under 30 on your budget teams to advise you on how you can use it and how you would train people, and especially the younger people would train the older doctors how to use it. Because that's older doctors have a fear of technology. And so that's the biggest learning that I came up with after just a couple of conversations with oncologists and doctors at UC San Francisco. So anyway, that's kind of my contribution. I'm not a doctor or AI person, but if you talk to the people and just ask them questions like this, they'll tell you everything about what the problems are, what they need, and the obstacles. The biggest one is budgeting. Unless the medical profession, the older doctors, and then this is addressing this 50 to 70-year-olds who make the decisions, unless you seriously listen to the young people who are interested in AI and VR, you will be stuck in the last century till you're gone. And it will take 20 to 40 years for the medical profession to catch up to technology. It will take you that long. It's not a technology. And they talk about technical innovation and diffusion. I said, no, it's just a mindset problem. For example, around the world, every medical profession in the world could do it next week if they wanted to. Next week, if they really wanted to, because we have all the models. We know how we're doing it. But again, this is a budgeting issue. It's a mental problem.
Well,
yes.
can I say something?
Yes, sure.
Okay, sorry to cut off the other speakers, but just to respond to what Sheridan said, the medicine is mainly funded through insurance companies, and they are not going to pay for something unless there's a proven clinical benefit. So that's one of the issues right now we have with trying to get AI adopted in hospitals is really you have to convince the insurance companies or convince radiology departments in hospitals that it's really worth the investment. I actually think that AI and VR and some of these other technologies will be adopted in other countries faster than in the U.S. Where there's actually a greater need because, for instance, there's not as many radiologists or there's not as many surgeons. So, an AI algorithm for analyzing chest X-rays, for instance, I think would be much more needed and valuable in countries where there are not a lot of radiologists. The remote surgery that I think will be deployed many places all around the world before it's deployed in the U.S. Another reason I say that is because the FDA it regulates and FDA is probably the most conservative regulatory agency in the world. So that's another barrier that we face here in the U.S. that other countries technologists don't face other places. As far as the applications you mentioned, one that I really liked was applying VR to radiotherapy or cancer therapy, because that's an area where, from what I've heard, they are very behind in terms of deploying technology. Theoretically, like when people are getting a radiotherapy treatment with high energy radiation, that can all be modeled physically. You can because the patients generally get a CT scan or a PET scan. It's very easy to create a 3D model of the tumor, and then the application of the X-rays or other radiation, that can all be modeled physically. But right now they aren't doing that. It's really surprising. They're actually just using like Excel spreadsheets from what I've heard. But all of that can be modeled and you can view it in 3D. And I think there are actually some, you might ask, like, why can't you just view it in 3D on a screen? But I think in some applications there are specific benefits to viewing it in virtual reality, because you get a very standardized view, and also it's more of a visceral experience, right? I don't think VR is necessary for every medical imaging application where you have 3D volumes, but I definitely think it has a role in certain applications.
I agree with you. I'll just respond. We use mostly 2D panels because for medical presentations, and we had 50 people, or we're online. Most people using flat panels. So what we would do to show the dimensionality is we would show the view of the world from the VR head person's view. So we had one person managing all the models, and they wear a headset, and we would project onto the big screen their point of view, so you could walk around and you would see how they're looking at the world.
Yeah, the education and collaboration aspect, I think, is another really important thing. And I think there's a lot of logistical issues, but it'd be really cool if you could, bring in a specialist from another part of the world for a specific case or something like that. Yeah.
Right. Yeah. I mean, right now, we do that for architecture, for like trees. And you can just go to any these sites and buy rocks and trees. We could build a garden in 5 minutes. We don't design it. We just drop and drag. So in the future, all human organs and cells will all be in a 3D database. And so you'll just drop and drag hearts and things like that from operations. Because it's easier to do that than to have to rescan every time. So it's like medical specimens. So we'll have these specimen libraries with hearts, livers, whatever, different stages with all the information attached to it. And then medical schools will just go there and there'll be millions of images and just drop and drag. That's the easy way to go. And there'll be a whole business just doing that. So companies who do medical organs in VR will make a fortune because they'll just sell them. You can buy, let's say you buy a heart for like $5, a virtual heart. That's the way I hate to say it, it's going to look like Amazon, a medical Amazon. Think of it that way. That's how you make it cheap and easy. So in the future, what's going to happen, I can tell you, it's going to be, maybe Amazon will do it, or Apple. You just, you order whatever you, either lease or you just buy it, your headset or whatever, tablet, and then you just go to the library and download. It's
for education.
Yeah, for education or research or whatever you want. Because you could put in all the Nobel Prizes in there too if you wanted to, and look at that in there. And if you're doing, like, what I would do is for cancer, for example, you take a very serious problem, and then you invite the whole world in there, all the researchers, and they share their scans, and then you comment. You have this whole discussion, just like we're doing today, around one organ. That's it. And then you just record it all. So that's the future medical school or research school. Yeah. So I think it's going to change. We don't know how, but we were all just brainstorming ideas on how. Now, one, I can tell you the other, besides the Amazon sale, the other one that was I showed it to some young researchers, and the first thing they said is, "Oh, I wish I had it because I applied to the NSF for a grant for funding, but it's very competitive. We probably would have won if we just had a simple model because they're using old-fashioned paper." And so I think because we use right now for architecture and construction, urban planning, VR is usually mostly used for marketing to win a project, to win funding. So I think doctors are pretty pragmatic people. They're just, and researchers, they're always looking for funding. I think the first killer app is going to be using VR to raise $2 million for your project. And once they do that, the world changes because everybody's going to copy.
Yes. Thank you. We have other speakers. Mr. Markley, I think you have time issue, so you can share your views. Then I want to give a chance to.
Yeah, I just had a quick question because I've actually been very much involved in a lot of different conferences and a lot of things going on and everything. And one of the things I've been hearing people have concerns about, even in the AI health field, is that will AI replace a lot of the jobs that we already have? Because I actually heard a speaker not that long ago saying that, radiologists and other folks that are doing these jobs, x-ray technicians, that those jobs may be gone. And therefore they will need to find other fields of employment, maybe going into AI. But some of these people are in a age range where they may not be able to get as trained as fast as they would like. And I'm actually a big fan of AI. I know that Facebook is now changed its name to Meta, even though everybody still knows it as Facebook and everything. And it seems like they're going more into that metaverse space. And a lot of that is going to be like us creating our real worlds with our families and everything else, but also being able to go into that virtual world. I think I saw an ad yesterday where they were like showing some kids going to a zoo, and the zoo animals were like talking to them and things of that nature. So we're having that kind of experience of augmented reality, virtual reality, and all of that in the fantasy world, in the creative world. And that's kind of the space that I come out of, creative and media. As I was telling Sharif, medical, not as much. I was the kid that was scared of blood when I was going to school and all of that. So not as much in the research and science field. But I was just wondering to my fellow esteemed panelists, their thoughts around that, and do they think that that could be a concern around AI, that it could be like a change in directions? We went from the agricultural age to the technology age, and now we may be going into a further advance of the technology age. We can call it the AR age. I just coined that, but I'm sure other people have coined it as well. But will that be kind of what happened when we had those other shifts, like when we went, if you go way back in history, from agriculture to industrial and industrial to technology? But I was just wondering what my fellow panelists' thoughts are about that, and how people can get engaged in being prepared, particularly if they're in my age range. I'm in my late 50s, and I know some of my friends are in their 40s, and even some in their 60s and 70s, and my dad's age of around the 80s and everything. So, maybe not as quick to jump on the bandwagon, even though I do know that the Black Metaverse, which is a group founded in Raleigh, North Carolina, and Virginia, I think that's where the two founders are, is actually one of the founders is 62. And I think he may have started it when he was in his late 50s and everything. I think he definitely told me he was in his early 60s. But that was just my quick ramble. And I hope that folks have some thoughts and maybe ideas as ways that folks can get engaged in this field.
Thank you, Mr. Markley.
Yes. Thoughts, if you want to hear them.
Okay. Yes.
But yeah, well, Geoffrey Hinton, who is considered one of the quote godfathers of machine learning and deep learning, he said a few years ago that AI was going to replace radiologists in the next few years. My experience, though, working in the field is that's not very likely. I think actually people in medicine don't really have to worry about AI replacing them in the next, at least in the next few decades. And what's going to happen actually is the medical professionals will use AI as a tool, but the reason it won't replace them, at least not right away, is because these systems are all very narrow in their focus. So in radiology, you have an AI tool that the AI tools, they do very specific things. And whereas the radiologist can bring in other information and about the patient's background, case history, et cetera, that can help them arrive at a decision. So the decisions
goes to the doctor to use that plan. But if they use the other three, it does not cost $35.
Sorry, what?
I'm sorry, Mr. Dan, please continue. I think yes.
Well, okay.
Mr. Dan.
Yeah. Where I would, so there's, so that's the first point. But I do think other professions will be impacted sooner, and there will be massive dislocation. So the obvious one is truck drivers, and the other obvious one is people working at McDonald's who are either the cashiers or even like some of the people in the back. They will be replaced by AI and robotics very soon, and much sooner than radiologists or medical people. So that's just my experience from and view just from working in the field.
This is very important. Even yes, Mr. David Smith, because
I will give a couple of other comments when we jump in this discussion, though. Dan, I agree with you in some context, but when I was on the Innovation Steering Committee, both at NCI and NIH, you begin to see differences there. For example, some of the work we did at Hopkins and at MD Anderson, your adoption rate is very, very high. At Hopkins, probably 30% of the doctors have computer science degrees also. And as you look at the doctors going into the practice today, like from the Dell College of Medicine, they're required to do computer projects as part of getting their MD. So I kind of disagree with a lot of your premise there. The work I've done inside of organizations like at Optum and United Healthcare and others like that, I see a much broader range. It's kind of like taking the imaging technology you're talking about that was used at NEMA and NGA and DOD. And yes, there were still people who wanted film, but that went away a long time ago. And so really the way technologies is adopted has changed. And it's much like Sheldon was talking about the semiconductor industry. I was the co-leader of the first semiconductor roadmap and an executive at Semitech. And the technologies we had in there very rapidly replaced older technologies. The secret to substitution analysis is when you have a technology go above 10% of the market share, it's going to go to its completion in the technology area it's designed for. And in healthcare, a lot of the technology is going to be in use of AI is going to be invisible to the doctors. It's going to be embedded into the tools and the processes and the other things the doctors use. It's like most people think when you turn the ignition key in your car, you're actually starting the engine. No, you're starting a process of computers talking with other computers before a signal ever is given to the engine. And you're really driving a supercomputer every time you get in your car to drive today. But we don't think of it as us driving a supercomputer, but that's what you really are doing. So to me, I think that's part of how AI in healthcare is going. And really AI in healthcare is very interesting because in 2020, the AI in healthcare was about $8.5 billion. And COVID changed a lot of the application of AI and the advanced technologies like AR as well in healthcare. And the AI marketplace in healthcare by 2030 is estimated to be about a $300 billion marketplace. And it's growing about 40% compound annual growth rate per year. So you see that type of change. It's not going to be by mortality substitution of the older doctors leaving the practice and new doctors replacing them, because mortality substitution isn't going to drive that type of market growth. You're really looking at technology substitution. And AI in healthcare is in still the bottom part of the S curve of technology growth. So it's beginning to go up the steeper part of the S curve now. And I think you're going to see that in healthcare very broadly. Part of the movement towards that, at least in North America, is there's a fundamental shift in healthcare going away from fee for services to fee for value. And you're still always going to have a fee for service because people have accidents and things. And doctors will be reimbursed, hospitals will be reimbursed from them. But the model in the United States is going to where doctors are going to make more money to keep you well than to just repair you if you're sick. And with regenerative healthcare and others beginning to take off now, and regenerative healthcare and others is heavily driven by different types of AI tools, because you've got to use the machine learning to begin to match it. Genomics is really a AI enhanced science that is being applied to be in both generating new types of medicines, regenerative healthcare, new ways to treat things less invasive, and to treat them in advance instead of reacting to them when they become a problem. All of those are driven by AI in healthcare. And you're going to see those elements continue to increase. And what's interesting with AI in healthcare, it can be applied in the most advanced medical environment, and it can be applied in some of the most backwater medical environments too. The automatic defibrillator is a great example. They are deployed in backwater locations where there's not a doctor for hundreds of miles, but can be used to bring somebody out of a cardiac episode and things. So and that's very much of an AI enhanced tool. So you're seeing it used in many different ways there, in many different things. And the whole healthcare education process is changing to adapt to that. In engineering schools that specialize in healthcare and medical devices, AI is top of mind for you to get degrees from research universities in engineering with a specialty in healthcare. So it's just part of the substitution curve.
Right. I agree 100%. Yeah, I was just addressing Mark Lee's question about whether medical professionals and radiologists will actually lose their jobs. And I don't see that happening for at least a decade. But certainly, I agree 100%. They're going to start using AI, and the people going through medical school today, they are often aware of that, especially in radiology. A lot of the young radiologists are all studying AI and trying to understand it because they know that's the future.
Yeah, it's in many of the fields, though. In cardiology, same way. You're seeing that growth there. But the places, though, Dan, where I kind of disagree is my last company before the one I'm in right now. We actually sold to one of the large healthcare groups, but it was all about using AI to help the practices. And this is where you have hundreds of doctors in the practice geographically spread out, understand how doctors treat patients, and particularly how doctors earn reimbursement for it. And I can tell you, if a doctor doesn't use the tools and they go down in the value matrix, those practices are cutting them.
Oh yeah, there's whole areas of AI we haven't discussed that say are behind the scenes. So in building,
it's a lot behind the scenes,
logistics,
and that's what's
scheduling,
really good about AI.
And then also running these scanners, and AI is being embedded into CT scanners, MRI scanners now, so that there's less radiation needed, and the MRI scan can be done much faster, and all of that AI is all under the hood, right? It's not, so I agree with you there too.
Yes, yes.
But Sharif, let me just say one last thing on this, because as you look at AI, and I'm going to come back to AI as a pure topic, the number of deals that have gone up tremendously during the COVID year and since. Before COVID in healthcare AI, you averaged about 100 deals per year for the last couple of years in funding. Last year, what we see this year, that number's jumped to 700-800 deals a year in explicitly AI for healthcare. And it's just so good. It's used so broad. And one of the places we miss AI in healthcare is the area of using natural language processing.
Sorry,
natural language processing is very important for the future of AI in healthcare.
Yes. Yes, thank you, Mr. David Smith. I'm sorry, Professor Donald, that you have to stay long time. I'm sorry, there are different issues actually come for today's discussion. Mr. Donald, I want to give you the floor. So I'm sorry about that you have to wait around 45 minutes. I'm sorry about that, because many important issues come. Can you unmute, please?
Yeah, it's kind of early for me to get up in the morning.
Yeah, I understand.
probably not going to do this very often, and it's kind of pointless of me to come here. But I was going to jokingly point out to Sheridan that Niels Bohr, the great quantum physicist, said that science progresses funeral by funeral. And I think he was saying the same thing about medicine, that science produced. But I just read a great book that I'll recommend to everybody called Genius Makers. And it's a detailed book on the history of AI. And AI was deep learning specifically. And it was driven by a guy named Jeff Hinton, and out of Toronto. And it's been around since the 70s. It's not something new. It just, we didn't have the computer power to actually make it work until GPUs came along. And it almost faded out, but this one guy just believed in it, and he kept it going for all these years, and then it started up again. And he points out something that Dan said, that it's very narrow. And he really doesn't believe in the idea of general intelligence. He doesn't think it'll work. He doesn't think it's possible to get enough data to do it. And he also thinks it's a dumb idea, because why would you want a medical computer to know how to pump gas? I mean, it just doesn't make any sense. And the question about that people have been asking about, will it put radiologists out of business, is missing a point about what doctors need to do, what their job is. Their job isn't a radiologist's job isn't just to interpret it's to be able to communicate with the practitioner so that they can come up with some sort of a way to talk to actual human beings, to figure out what this human being is going to do with their life, to be able to use this information in some sort of a way to do something so that they can do actual actions in their human lives so that they can get better. And it's extremely difficult to get people to change what they're doing, to get people, we look at it right now, all the people who refuse to take the COVID vaccine. I mean, this is multiplied by every kind of thing that people do in life. And a lot of what doctors do is to be able to try and get into the world and understand the needs and objections of the patient. So that's one thing. Some of the things that AI is used for in medicine that you don't even think of is your Fitbit requires AI. It requires deep learning, because the way that Fitbits work is that every time you step, the Fitbit has sensors that feel the pulse, and then they have proprioceptics, so they know what position you are. And with just that information, they know when you've taken a step. How do they know that? I mean, that's amazing. And what they've done is they've just taken countless people, and they've measured them, and they've come up with the patterns so that they know when you're taking a step. So that's a use of deep learning in medicine. And then knowing that information, you can give people feedback so that you can get people to be able to walk more. And it works with me. I mean, I keep track of how much I walk, and if I haven't been walking enough, I take the time to do that. Google had a project where they hired an army of nurse practitioners, and what they were doing was taking baseline health calculations from people, and they were trying to discover what the idea of baseline health was. And again, it was the same sort of a thing, where what they were trying to do is be able to establish the patterns of basically just like it takes a million faces to be able to decide what the average face is, so that you could train a deep learning. They were trying to be able to get enough data about health to be able to train deep learning systems so that they could find out something about health. Now, it doesn't seem that it's panned out too well for them. They spun that division off to Alphabet, and shrank it quite a bit. And so those are two ways that deep learning is being used in the actual way that deep learning can be used. I want to say this whole thing about trucks being used in deep learning. I really want to recommend, when you read something about AI being used for something, that you read past the headlines, because there's a headline that Amazon is using trucks, self-driving trucks. Wow, finally, Amazon is going to start delivering their packages using self-driving trucks. If you read the thing, what it actually said is that they drive a 7-mile loop with nothing on it. You know, they're not going to drive a truck in downtown Boston in the rain. That's not going to be happening anytime soon. They're with no obstacles, no stoplights, no pedestrians. A self-driving truck can drive a 7-mile loop. We're so far from self-driving cars that it's not even funny. Basically, a lot of the ideas that we have about AI and how far along it is are just our height, and it's an incredible amount of height. So I'd recommend you read the book Genius Makers, because it talks about it. One thing is, like, when it learned to play Go, the way it learned to play Go is it basically set up a system where it played 1 billion games of Go against itself. And, you know, you can't do that in normal life. You can't get that much data. And so that was probably what happened to Google when they were trying to be able to get enough health data to be able to get any meaningful patterns out of it. So I think that if you realize what AI and deep learning are really good for, you can start seeing the patterns that it's useful for. We're using it now, and that's really what of what I wanted to say.
Thank you. Thank you, Mr. Donald, for your excellent analysis. I have to go for concluding remarks, but for my perspective, today's session was really great session. Especially, I believe many people, they have many confusion, especially application of AI in healthcare industry and AR and VR. I think they can learn a lot. I request all of our audience, please share our content as much as possible, because I know in this developing world there are many confusion, but today's session is very valuable. Mr. Sharidan Tarson, I know you have important meeting. What's your concluding remarks?
Okay, I'll try to keep it short. 3 points. One, I first agree with Dan. AI will assist humans and enhance it, because you need humans to analyze things beyond just the machine itself, because humans will see things that the AI may miss. Secondly, AI is probably going to be used for cutting system costs, not just human costs, because the systems are often expensive. So I think, and then as for results, I think there's going to be a lot of testing, probably overseas first, and then FDA, and gradually it'll be used for actually achieving different results. And then finally, point solutions. Ed Feigenbaum said a long time ago at Stanford, he was an expert, that generalized AI is very difficult, if not impossible to do, because the human brain is so complex. All the ones who tried generalized failed, and the only ones that succeed were point solutions on specific problems. So given the fact there are thousands of AI companies and they all have to focus, the idea of trying to be a generalized against all these specialized solutions is I think a fool's errand. I think what will happen, if anything, this point solutions will be acquired by the Googles and Apples of the world and integrated into a larger system. But anyway, those are my points. But thank you so much for your time.
Thank you, Mr. Sheridan, for joining today's session. Mr. Dan, what's your concluding remarks?
Yeah, unfortunately, I really have to leave as well. Well, I think it was a good discussion. I don't think we got into a lot of specific details, really, but I think we kind of provided a good overview. I'd be happy to come back at some point later and delve into specifics on some of the work I've done on doing automated measurements with AI. So, you know, that's a specific application I've worked on and been interested in, like automatic measurements of plaque in the aorta or fat, the amount of fat you have in various parts of your body. Another thing I guess I mentioned is a really good book on this subject is called Deep Medicine by Eric Topol. I have some disagreements with Eric Topol because he really slowed down he really was telling the FDA to slow down the approval of the vaccines, which I really disagree with. But Eric Topol, he did write a very good book on AI for healthcare, and basically his conclusion is very similar to a lot of what we've already said, that AI is not going to replace doctors, at least not anytime soon. But they're gonna be using it, and they're gonna have sort of like a dashboard. They're gonna, like when they are looking at a patient's data or the scans and lab results and stuff, they're going to have a dashboard with a lot of different AI tools and outputs that they're going to be looking at. And eventually there will be trust built up in these systems. So to the point where a lot of the data analysis will be done by the AI. And then the doctor's role will be more looking at the output of the AI or multiple AIs, synthesizing that into a decision, and then talking to the patient. So right now, because doctors are so overworked, especially radiology, they don't talk to the patients very much. And there's a lot of research showing like when you spend more time with patients, like it really improves the experience for the patient and reduces stress and stuff. So in the future, the vision that Eric Topol and a lot of other people have is the doctor's role will move more toward the human side, interfacing with the patient. And I think that's a really positive vision for the future. And again, it's not replacing the doctor, but the doctor is changing the way they work and what they do. So that's I think a nice vision to look at.
Thank you, Mr. Dan. Professor David Smith, what's your concluding remarks?
I actually enjoyed the discussion, a very different format than normal. But AI is a field that is actually beginning mature. My first involvement in AI was at the MCC Consortia back in the early 80s, where we had a whole program doing nothing but AI, including Doug Lynette working on Common Sense AI and moving that forward. AI in healthcare, it's here, whether we like it or not. Many of the watches today have the built-in sensors and things that are automatically using AI to help monitor part of your health. We're seeing in the Internet of Things growth for the medical field, a lot of AI being applied in the Internet of Things. You walk and look at even things like signing up on a portal to access your doctor or review your medical records. A tremendous amount of AI used there. A lot of healthcare records are still written text. So you're seeing AI, machine learning, and natural language process being used to get greater insights out of that. AI is not going away in healthcare. Great opportunity today for innovation, for entrepreneurship going forward. If you look in any of the incubators around the world, almost all of them have AI applied in healthcare in some of their portfolio companies. So great opportunities going forward. And, it's a market that's growing about 40% a year. So great opportunities for innovation and for new business.
Thank you. Mr. Donald, what's your concluding remarks?
Well, I just wanted to point out one other example, which is during the COVID epidemic, a couple of places asked me if I would use my Fitbit to monitor my health. And so every day I would I would let them upload my Fitbit data, and I would sit down at the computer and I would tell them how I felt, basically, and I'd tell them who I was in touch with. Was anybody around me sick? How did I feel? I do that every day. My wife did it too, and they recruited a bunch of people to be able to do that, and they knew my zip code. I think I might have even given my address. I forget. And I don't remember who it was. I think it was Johns Hopkins, but it was one of the big medical universities. And what's so cool about that is that if they do that with a ton of people, lo and behold, they're getting the data. And remember what I was saying about Go, playing a billion games of Go. Well, you can do, when the COVID epidemic came along, they developed a model that they never had before of epidemics. It was a great story. It was developed actually as a science fair project by a high school girl. And they found that closing the schools was one of the things that they could do, was absolute best thing to help it stop spreading. But how do you know that, and masks were also fabulous way of stopping spreading, but how do you prove that? Well, what you can do is you can take your model and then you can run it against real data. And so if you have the real data, you can train your AI with the model, and then you can use the real data as structured data, so that you can actually train the AI with the actual data, so that your AI becomes better and better. So then what winds up happening is that if people are willing, you can watch their Fitbits all the time, and lo and behold, you can spot an epidemic as soon as it starts. And that's an incredible use of it that could be super, super valuable. So I think that opening our minds and thinking about it, we can realize that there's an incredible amount of uses for this that could really benefit mankind. So I would think that it's something that's going to be very valuable to us in the future.
Thank you. This is really, really great discussion, because few things I want to add. Number one, there are many misconceptions about AI and VR. I think our audience can learn. Even I can remember 3 months ago, I have to convince some of the people about these AI related things. And I find that today actually this argument come, and I believe that how Mr. Dan and other speakers actually give their feedback and opinion, this is very important. Second things, especially I know that we are actually sharing our content with different university and corporation and government officials. They can learn how to do like intellectual discussion. Even though if you have argument, you can respect each other's and you can continue your discussion. These two important thing is very important. And beside that, from World Talent Economy Forum, we have our own academy. We start to train many people in developing nations. So those who are interested to train people, because because knowledge is very important, and getting knowledge from right kind of people also very important. So especially the academic people, if they get their training and information from today's speakers, I believe it will be very valuable for them. So thank you everyone for joining today's session. If you are interested to join in our academic part, because every day we have our School of Talent Economy, then World Talent Economy Forum, you can contribute. And today's session is really great and really helpful for our audience. Thank you, Mr. Donald. Thank you, Mr. Dan, and thank you, Professor David Smith, for your continuous support for World Talent Economy Forum. Thank you, bye-bye, and take care.
Thank you.